as well as 12.4. Sorry, just struck me that I didn't mention whether it is separate or together. Can I just ask whether anybody did it in a continuous manner for this homework? So everybody on separate exercises. So we submit separately, yeah? Okay? Okay. Yes. Chapter 13 will be separate from chapter 12 lah. These two, you did it together, is it? Okay, if you did it together, then anybody else did the same? Okay. I explain to you all why I don't like it to be together lah. Okay, with this number of questions, it is very mentally draining on me to mark one whole very thick stack. It's just my mental capacity. I find it very scary to mark one whole stack like that lah. Okay, so it's like it feels like it's never ending. Okay, so that's why I prefer it to be separate, so that my goal itself is seems shorter rather than it is draining. I have to sit through 6 hours of marking the entire thing. Okay, it is very tedious to mark. Alright, so that's why I prefer it to be separate. Okay, if you have done it together, okay, then you submit together with 12.3 stack. Once I finish with 12.3 stack, then I'll pass it over to 12.4 stack to actually mark. Okay, so that'll be the case. Okay, so okay, now looking at 12.3, any issues with question 2C, 2D, how about 3B? Okay, how about question 4? Okay. How about question 8? 10, 11. Okay, then let's also get through 12.4. Question 12.4, question 2A. Yes, Regine? 2A, is it? Okay. How about 2C? Okay. 5, 7. 5 and 7 don't have, Okay. Question 4 first. Okay, we have the y equals to x times square root of 5 minus x squared. We want to show that dy over dx is equals to that. So we could only use product rule since 12.3 is about product rule. Okay, so we keep the left side, differentiate the right side. If it helps, you may want to actually just simplify or rewrite our y first into as such. So keeping the left side, differentiate the right side. Okay, the differentiation of the right side will be half times 5 minus x squared to the power negative half times negative 2x. Followed by adding on 5 minus x squared to the power of half, differentiate x will get 1. Okay. Now we go through simplifying, cancel away the 2, we will get negative x squared over 5 minus x squared. Since the power here is a negative, it goes down to the denominator. Then after that, the term on the right will be 5 minus x squared. And then we need it to be in the same single fraction because that's what the question wants. This means that my original 5 minus x squared square root needs to multiply with another one. In order for both of them to share the common denominator. So two square roots of the same thing multiplying each other will result in no more square root. And therefore we have 5 minus 2x squared over square root 5 minus x squared. Okay, so that's how we show it. Okay. For question 8, just wondering, is part I that issue? For question 8, sorry, for us question 8, part I. Okay, so product rule again. We rewrite our y into x to the power of half, x minus 3 to the power of 4, dy over dx, keep left, differentiate right, plus keep right, differentiate left. Okay. Then after that, simplify. Right? You may leave your answer at this if you want to. Okay, it's nothing wrong. But let me just do a quick check of what your textbook has. This is question 8. Okay, what your question has is a single fraction. So if you want to leave it like that, it's okay. Otherwise, if you want to express as a single fraction as per your textbook's answer key, you will have to multiply the term on the left by a 2 square root x before we can make it into same denominator. 4 times 2 is 8, square root x times square root x is x. Then at this juncture, you can factorize out the x minus 3 cube. We will have 8x plus 1 more x minus 3 left. Which explains why our answer would be left as this. Okay, which you can also factorize out the 3 over here. Honestly, it doesn't matter, alright, whether you leave your answer up to this stage or you leave your answer up to this stage. Since the question did not specify to what extent should you simplify to. Okay? Being able to do your product rule and leave until here is good enough already. Okay? Then part 2. So dy over dx equals to 0. Okay, if you had left your answer to this extent, just showing that alternative first. Okay, your dy over dx will be equals to 0, and we want to find the value of x. So to simplify this, you can shift the fraction over to the right side. And then after that we cross multiply. This is over 1, so this becomes this. times already. We cannot cancel out the x minus 3 like that. Okay, you need to actually shift this thing to the left and factorize. Okay, the reason why we cannot cancel is because x minus 3 can be equals to 0, and by cancelling we're actually dividing. Okay, we cannot divide by 0. So factorize out x minus 3 to the power of 3. We are left with 8x plus 1 more of x minus 3. In other words, x is equals to 3 or x equals to 3 over 9, that is 1/3. Okay. So there are 2 points, 3 and 1/3. Any questions? Next, we look at question 10. Okay, we're given an equation of the curve. We want to find the gradient of the curve at each of the points where this curve meets the line y equals to x. So that means that given a curve, right, okay, there is a line y equals to x, and then they coincide, they intersect at 2 points. We want to find the gradient, that means our dy over dx value at these 2 respective points. Okay, so as a diagram-wise interpretation of the question, this is what we're referring to. Okay, so if you want, okay, since you're going to be looking for gradient, you can start off by doing your differentiation. Okay, so keeping the left side, differentiate the right side. Okay, then plus keeping the right side, differentiate the differentiate the left. Okay, and we will have negative x squared over square root 9 minus x squared plus 9 minus x squared squared. Okay, so this will be our dy over dx. Okay, then since I want to know the exact gradient value, that means I must know what is the x coordinate at these 2 points. Therefore, we look at the curve intersection with the y equals to x. So we need to solve simultaneously the equation of the curve as well as the equation of the line. Okay, and we have x equals to x square root 9 minus x squared. Again, cannot cancel away the x. You need to do by factorization. we get x equals to 0, or 1 minus square root 9 minus x squared equals to 0. From the second equation, 1 is equals to 9 minus x squared square root. 1 equals to 9 minus x squared. X squared equals to 9 minus 1, that's 8. So x is either at 0 or square root 8 and negative 8. X equals to 0, y equals to 0. Okay, why are there 3 points? Sorry, why are there 3 points? Put into where? Put into dy over dx. But why are there 3 intersection points? Square root. Sorry, I just want to generate and see how the curve looks like. Yeah. Just want to understand how the graph looks like. Y equals to x square root 9 minus x squared. Oh. Okay. Because actually the graph, right, of y equals to x square root 9 minus x squared actually looks something like that. Okay, it is our cubic one, right? Okay. So this is the shape of the curve. Okay. That's what I generated on my computer. So that's why there are 3 points of intersection. Okay. So shouldn't be rejecting anything at this point. So you find the gradient. Square root 8 gradient is negative 7. Okay, so we get 3 different gradients. Okay, so therefore this will be the 3 answers for the 3 different points of intersection. questions for this? Alright, moving on to question 11. Question 11 says we want to find the coordinates of the point on the curve at which the tangent is parallel to the line 5x minus y equals to 0. So we have this curve. It should be quadratic since this is a quadratic function. Okay, at which the tangent at somewhere, oops, the tangent at somewhere is going to be parallel to the line 5x minus y equals to 0. Okay, so these two lines are parallel. For parallel lines, we need to know that the gradient will be equal. Okay, so therefore, we first find out what is the dy over dx for our y. Either you can apply your product rule, otherwise you can expand, then you differentiate also can. So in this case, let's do our product rule. Keeping the left side, differentiate the right side, you get 1. Keep the right side, differentiate left, you get 3. So your dy over dx is equals to 6x minus 7. Okay. Given that we have the line 5x minus y equals to 0, that means y equals to 5x. So the gradient of the line equals to 5. In other words, the dy over dx must be equals to 5. So x is equals to 2. So that's the x coordinate. Then to find the y coordinate, we place it back into the curve. That is equals to 0. So the coordinates will be at 2, 0. Okay? Questions regarding this? Alright. Last one, let's look at 12.4. I'm guessing that for question 2A and 2C, the reason that you are asking for it is because you're not able to simplify to get what the answer he has. So let's give it a try. Let y equals to square root x over 1 minus x. dy over dx using our quotient rule. Keep the bottom, differentiate the top. Okay. So we will bring down the power half, power minus 1. Okay, differentiating x itself will just be 1. Minus away, keep the top, differentiate the bottom. And then bottom square. This part here, we have 1 minus x over 2 square root x plus root x over 1 minus x bracket square. We can try to make the numerator at the top to have the same denominator. Okay, make sure you differentiate your as in distinguish your fraction line. Okay, the length matters. Alright? So then your denominators now can be placed together. Okay, and then we have this as our answer. Part C. Applying your quotient rule should allow you to arrive at this. Then we make the numerator share the same denominator first of 2 square root 3x plus 1. Alright, then after that, we can combine the denominators together. Such that we get 6 bracket 3x plus 1 minus 9x. So this will be the answer. You may, instead of having power 3 over 2, you can have it in this manner also. Okay? Yes. Question 7. Okay. Right? But before I go into question 7, any issues with question 12? Okay? Please do check through your own work also. Okay, I don't want later the work come back to me and then you left it blank, then no corrections, nothing at all. Alright? Then it's very frustrating that you waste your time like that. Okay, question 7, you want to find the value of dy over dx when x is equals to 0. That means that we first find out what is dy over dx. Keep bottom, differentiate top. How much space? I shift it here. So we get our dy over dx to be like that. And then we want when x equals to 0. That means 0 minus 3 over square root 1 whole square. So we get negative 3 over 60. Okay? Yep. See? Why you want to do that? For your satisfaction? Okay, just make sure it's one of it, not two. Yes, actually. Okay, you know the question, we pass your homework down to the front.